In this example, we are going to determine the intervals on which the function f is concave upward and the intervals on which it is concave downward. We call concave upward. That means the second derivative is greater than 0. Concave downward, where the second derivative is less than 0. That means we are going to first find the derivative starting from the first derivative and then the second derivative. When you find the first derivative, make sure the function is in the form of the power function, so then we can apply the chain rule or the general power rule. So f prime is 1/2 the quantity 8x squared plus 7 to the power negative 1/2 and multiply by the derivative of 8x squared plus 7, which is 16x. And the first derivative now simplified to be 8 times x times the quantity 8x squared plus 7 to the power negative 1/2. Since we simplify 2 and 16, and then we write the negative power into the positive power, then we get 8x divided by the quantity 8x squared plus 7 to the power 1/2, which means we have 8x divided by the square root of 8x squared plus 7. But our goal is to get to the second derivative to determine the intervals of concave up and concave down. We're going to continue with the second derivative. The second derivative from what we have, this is the quotient form, so we're going to use the quotient rule. So the top is high, bottom is low. Therefore, the d high is 8, the d low is from the general power rule. So 1/2 quantity 8x squared plus 7 to the power negative 1/2 times 16x. Then simplify again to get 8x divided by square root of 8x squared plus 7. Then we put together using the quotient rule to find the second derivative. That gives us, by using the formula low d high minus high d low, draw the line low squared. Draw the line before we forget the denominator. The low is the square root of x squared plus 7. The d high is 8 minus the high quantity, which is 8x, times the d low, which is the expression is x divided by square root of 8x squared plus 7, all divided by the low square, which is the quantity of the square root 8x squared plus 7 squared. Now we're going to simplify. At the simplify step, we start with the numerator. The numerator has the common factor 8 and 8 here. So we're going to take the 8 out of the numerator expression and see what left over for us to take care of. So we have square root of 8x squared plus 7, and then subtracted by, so we multiply this together to becomes 8x squared divided by square root of 8x squared plus 7, and all divided by, now square root and power 2 take care of each other, becomes 8x squared plus 7. Then we're gonna use the property in algebra to simplify it further. When you divide, that means multiply by the reciprocal, so we're gonna write the numerator 8 times the quantity square root of 8x squared plus 7 subtracted by 8x squared divided by square root of 8x squared plus 7. Divide means multiply by the reciprocal. Now we write in the less complicated form, and then we work on the quantity that has the subtraction. We're going to use the common denominator that will give us, common denominator, square root of 8x squared plus 7, and the first term now becomes 8x squared plus 7 from multiply top and bottom by square root and square root. This quantity is subtracted by 8x squared, and outside is multiplying by 1 over 8x squared plus 7. In the parentheses, we can simplify by cancelling 8x squared minus 8x squared. Now we have 8 and 7 multiplied to be 56, where the denominator you can merge them together as the quantity of x squared plus 7 multiplied by square root of 8x squared plus 7, and this is your second derivative. Okay, from the second derivative we're going to use it to find the hypercritical. To find the hypercritical point, first case we let the f double prime to be 0. Second case we let the f double prime to be undefined. That means for the f double prime equals 0, we look at the numerator equals 0. In this case 56 is never be 0, so that one out the way. And then the second case, when the f double prime undefined, that means when the denominator equals 0. So we let the denominator 8x squared plus 7 times the radical 8x squared plus 7 equals 0. And this one, if we merge this together, this is 8x squared plus 7 to the power 3 over 2 equals 0. Rest both sides by the power 2 over 3. That becomes 8x squared plus 7 equals 0, because 0 raised to any power going to be 0. Solve for x. 8x squared equals negative 7, or x squared equals negative 7 over 8 would never be true, since it is power 2 or squaring number. Is always non-negative. So that means in this case we do not have the hypercritical point. And if there is no hypercritical point, that means there is no inflection point. We can verify it by drawing the real number line, and this is the line to represent the sign of f double prime, where f double prime is 56 over 8x squared plus 7. The note that we have to pay attention about, whatever the x that you fit into this term is always positive. If you have the positive on the denominator, where the 56 always positive, therefore the whole real number line here, the sign of the f double prime gonna be positive. That means it's gonna be concave up for the entire real number line. So this is what we got. So no concave down.